Welcome everybody to another talk in our series. It's great to see you all again in your smiling faces. I want to welcome Tali Sharot, who comes to us from University College London, and also she's a visiting professor at MIT, so you may really be coming from there, geographically speaking. At Cornell, we like to think of ourselves as integrative scientists. You know, the series that we're having right now is a result of an integrated collaboration between psychology and economics. And I must say, I think that Tali is a member of our tribe. She is vastly integrated. She got her degree in psychology and economics, her master's degree, and then received her PhD from NYU also in psychology and neuroscience. And her work really blends several bases of emotion, cognition, decision-making, optimism, anxiety, depression, all of these incredibly interesting and incredibly important topics. I was really more familiar with her work in journals. She publishes in, you know, those household periodicals like PNAS, Nature Neuroscience, Journal of Neuroscience, those kinds of publications. So I was really more familiar with those publications, and I know most people in the field are. But in preparation for introducing you, I found that you have a vast other life, too, as a science communicator. And science communication is extremely important here at Cornell. We have a PhD that we offer in science communication. And we think it's very important to connect the world of the laboratory with the world of problems and try to do something about it, which your work exemplifies. Tali is an amazing science communicator. You know, some people get their work covered by things like Time magazine. She writes the article that's on the cover of Time magazine, and it's beautifully done. So you have this magnificent technical work in places like PNAS, but this lucid prose that's written by you in Time magazine and various other places. She's given a TED Talk, of course, 1.5 million views and counting. It's amazing. So she's gotten all kinds of awards. I believe the Society for Neuroeconomics gave you an award, Early Career Award for 2016. It's amazing. Early Career Award. There's so much that you've done.
That's what my mom said. She's like, early or young?
I know. We're in a permanent state of adolescence in science. Her recent work, if you look through her list of publications, you just can't help but be excited by the ideas. The latest one, The Brain Adapts to Dishonesty, Nature Neuroscience, I highly recommend. Models of Effective Decision-Making in Psychological Science, How Do Feelings Predict Choice? Forming Beliefs, which she's going to talk about today. She also has a book coming out on beliefs that's going to be available in September of 2017. Her books on the optimism bias are already available through Amazon and other vendors of your choice. So she studies motivation, emotion, how the social interaction, reward and punishment all interact to determine our expectations of the future, our everyday decisions, our memories, our abilities to learn. And she's interested in doing this to enhance people's well-being, as we said, which is a wonderful purpose. And this kind of multidisciplinary approach really has promise for doing that. So without further ado, I'd like to give a warm welcome to Tali Sharot.
It's great to be here, first time at Cornell. So I will be talking about how humans form beliefs and the role of emotion, affect in that process. So why should you care about beliefs? Well, beliefs influence human action and well-being. For example, if a parent believes that vaccines causes autism, they may decide not to vaccinate their kid. If someone believes that climate change is not a serious problem, they may vote against the Paris Agreement. Beliefs also affect mental health. If we falsely believe that the environment is dangerous, that can generate anxiety. So classic models assume that we use the information available to us rationally to update our beliefs. But there are many examples that suggest that that may not be a case and that there's quite an intriguing gap between the evidence that's available to people and the beliefs that they form. So let's take more of a formal example from the domain of health. So in this study, patients at risk of Huntington disease were asked about their own likelihood of carrying the Huntington gene. So these were all people who had one parent with Huntington disease. That means they have a 50% chance of carrying the disease, of carrying the gene. If they have the gene, they will eventually develop the disease, which is a terrible disease and ends in early death. And so their perceived likelihood of carrying the gene was compared to the perception of a doctor who was assessing their motor symptoms. And what you can see here is that the patient's estimate of their likelihood of carrying the gene was 50% or less, and that included those individuals whose symptoms were so severe, which is here on the x-axis, that the doctor estimated the probability of carrying the gene and actually having the disease as 100%. And what I want you to notice here is as a patient's symptoms become more and more and more severe, they don't necessarily update their beliefs. So what this study highlights is a gap that we often see between people's beliefs and the evidence available. And this is just one example. I mean, I like this study, but I could have chosen from hundreds of different examples from the domains of health, politics, relationships, all showing this gap. So one of the aims of my research program is understanding this gap. And let me tell you why I think that's important. So there's three main reasons. The first one is theoretical. I don't think this gap is just an intriguing phenomena. I think it actually provides a unique window for understanding how people learn from their environment, just as systematic mistakes of how toddlers speak clued us into how the brain acquires language. The second reason is practical. If we know where the gap is coming from, we might be able to reduce it in certain circumstances to help people make better decisions. For example, perceive their own medical conditions more accurately given the evidence that's available to them. And the third reason is that this gap is related to mental health. So what I will show you in a minute is that this gap changes its shape in affective disorders such as depression and anxiety. In those disorders, what we see is that people's beliefs are actually tend to be worse, more pessimistic than the evidence that is available to them. So my approach is somewhat different from the classic approaches in highlighting the effect of emotion in how we form beliefs, and as such can explain the gap. And I think emotion affects the way that we form our beliefs at least two important points in this process. And the first point that I will talk about is how information is used to change our beliefs. And research that my colleagues and I have conducted in the last few years suggests that the way that we use desirable and undesirable information to alter our beliefs is different. We use different rules, different neural mechanisms underlie how we use good and bad news to change our beliefs, and it also has different developmental trajectories. So I'll briefly go over this research and then go on to some unpublished work as well. Okay, so to try and understand how people use good and bad news to change their beliefs, we developed a task that we call the belief updating task. So in this task, we give people 100 or 80 different events that can happen to them in their life, for example, burglary, and we ask them about their average likelihood of experiencing this disease. So the subject simply puts in their perceived likelihood. Let's say he thinks it's about 40%. And then we give them information about the average likelihood for someone like them, their age, living in their city, to be burgled. So in London, it's 30%. And we do this for 80 different events. And then we ask people again, what is the likelihood of you being burgled? So we want to know how people use information that we give them to alter their beliefs. And what I will show you in a minute are statistics showing that when people get good news, such as in this case, when they learn that the average likelihood of experiencing a disease is lower than what they thought, they tend to update their beliefs quite a bit. So they would say, okay, maybe it's 32%. However, when they get bad news, for example, when they learn that the likelihood of being a victim of card fraud is actually higher than what they expected, we don't see as much of an update in belief. So people say, my likelihood of card fraud is 20%. We tell them, no, it's 30%. They say, well, still think it's 21%. Okay, this is, of course, extreme, but let's look at the statistics. So what I'm plotting here on the y-axis is the difference between people's first and second estimate, so the absolute update in their beliefs, when they get good news in blue and when they get bad news in red. And what you can see is that they do update their beliefs in both cases, but they significantly update their beliefs more when the information is desirable, when it's better than expected. And this is quite a robust effect. In this first demonstration of this effect, we find it in about 80% of the participants. What I'm plotting here is a difference between the blue and red bar. So the bias and positive numbers means a positive bias. And you can see it's in about 80% of the population. So what's underlying this effect? Well, we control for a host of different factors. For example, we have people rate all the events and how vivid they can imagine them, how arousing they are, how good or bad they are they familiar with them, have they experienced them in the past. We control for the priors, for the first estimate. For the memory, we ask them at the end of the study, so what is the average likelihood of burglary? What is the average likelihood of being a victim of card fraud? So people don't have a bias in their memory for the information that's better or worse than expected. It's just how they use it. We control for whether they get high or low numbers. So half the time we ask them, what is the likelihood of experiencing the event? But half the time we ask them, what is the likelihood of never experiencing the event? So we dissociate high and low numbers with good and bad news. That doesn't matter. It's not a ceiling effect. It's not a floor effect. OK, so what's underlying this effect? Well, according to classic theories, people learn from what's known as a prediction error. So a prediction error is simply a difference from what you predict the outcome will be and what the outcome is. So if I predict I will get $100,000 and I get $100,050, well, that's a positive prediction error because I got $50 more than what I expected. And the next time when I need to predict my salary, I will update my belief according to this prediction error, the difference between my prediction and the outcome. So in our study, there's no outcomes. There's only information. So it's not quite a prediction error, but we thought, well, maybe it's something similar, which we call an estimation error. So that's different from your estimate, your prediction, and the information that you received. The information is not real outcome. It's still ambiguous, but it is information. And our idea was that just as in classic reinforcement learning, people will learn from a prediction error, people would learn from an estimation error, but perhaps they learn from an estimation error differently when that estimation error suggests you should revise your beliefs in a positive direction versus in a negative direction. So to look at that, what we do is for each subject, we look at all the trials and we relate the estimation error to how much they update their beliefs. So this is one example subject, subject number 1. In blue, you see trials where people got where he got good news, and in red, trials when the subject got bad news. And what you see is when they get good news, there's a tight linear correlation between the error that they make and the update that we see. So this is kind of textbook, right? You'd assume that larger errors will result in larger update, right? That's kind of clear. However, for negative trials, when they get information that's worse than expected, this relationship starts breaking down. So it's not a tight linear correlation. And we try to model our data using all sorts of models, complex models, simple models. And the model that fit best is quite a simple one, where the update is simply equal to the estimation error. So the estimation error is a difference between the information or the news that you get and your prior, i.e. your first estimate. And you multiply that by a weight, alpha. We sometimes call this alpha a learning rate or just a weight. However, the model that fit best was one that had two alphas, one for good news and one for bad news. And when you look across individuals, you see that this alpha, or this learning rate that you get, is much, much higher for trials where you get good news. Okay, so when you get good news, the weight that you put on your estimation error is about 0.75. However, when you get bad news, it's only about 0.35. So this effect has been replicated many times since by us, by other people around the world, both directly and conceptually. And I'd like to show you a few of the most interesting conceptual replications. The first one is by a group at MIT led by Josh Krieger. So what Josh did, he collaborated with 23andMe. So 23andMe is an online company where you send them your saliva and they send you back personalized genomic information. And based on that information, they tell you what your likelihood is to experience all sorts of diseases relative to the population. So what Josh did, he simply asked clients before and after they received that personalized information about their likelihood of experiencing the disease. And so what he found was that when people got information that suggested that their likelihood of experiencing the disease is not as high than they thought, right? Good news, they updated their beliefs quite a bit here in blue. So after they received genetic information suggesting actually you're less likely to experience Alzheimer's than you thought, they updated a lot. However, when they received bad news, so when the personalized genomic information suggests that they're more likely to experience a disease than they thought, they didn't update as much. So basically just replicating what we found in the lab, but in the real world. And what I'll show you at the end of the talk is that this has real world consequences as well. Another interesting expansion is by a group in France. And they've done quite a few studies now that are just coming out now. And they're all looking at just basic reinforcement learning paradigms and showing that even in basic reinforcement learning paradigms, people learn better from positive estimation errors than negative estimation errors. And they do a lot of different variations of this. You know, the outcomes can be only reward versus no reward, or only loss versus no loss, and all of those combinations. And every time they found the learning rate is greater for positive outcomes than negative outcomes. So this is a bit similar to what I was saying about you expect $100, but you get 105, versus you expect 100 and you get 95. So this was great. It was quite surprising to me because I always thought that what we found was happens because the information that we give is ambiguous, right? Okay, so the average likelihood of divorce is 40%, but you use other information to rationalize away that this is not you. But this suggests that it's even when it's actual outcomes that are a little bit more difficult to interpret in the way that you want to interpret it. And the last study that I want to tell you about is one that was conducted in August, where 1,000 Americans were asked to predict the results of the presidential election. And back in August, 73% of the participants believed that Clinton was going to win, and 27% predicted that Trump was going to win. Now, they asked them, who do you think is going to win? They asked them to put a little tick on a scale that went from Clinton to Trump. So if you're 100% sure it's Clinton, you put it right next to Clinton. If you think, oh, it's 50-50, you put it in the middle, and so on. Okay? They also asked them, who do you want to win? So this was surprising to me, but it was about half-half. So 54% wanted Trump to win, and 46% wanted Clinton to win. And then they gave them results of a poll. And different people got different polls. Some of the polls suggested a Trump victory, and some of the polls suggested a Clinton victory. And then they asked them again, who do you think is going to win the presidential election? What they found was that people altered their prediction if the poll was something that they desired. So if you're a Trump supporter and you hear that the poll suggests a Trump victory, you would move your scale quite a bit next to Trump, whether or not you thought before that Trump was going to win. So what mattered is whether the new information fit people's desires, not whether it fit their priors. Yeah?
Do you know if there's been any studies where instead of self-relevant stuff you predict for someone else, so like the 23andMe, but say it's just another person as opposed to...
Yeah, so there's a bunch of studies from a group in Germany, from the Max Planck, and I have always trouble pronouncing the name, Kuzinova Bujana is her first name. Yeah, so they've done a bunch of studies that have been published using the same paradigm. They make our paradigm better by having the information online when you put the new prediction. So there's like no memory effect at all. And they do it for yourself versus other. What they find is that the effect is greater for the self, but it is present in other as well. There's a lot of other interesting finding of how it relates to trait optimism and so on. So if you look those up, there's a few of those studies. Yeah. Okay, so all of these studies suggest that we learn better from information that's better than expected than worse than expected. There's also quite a few studies suggesting that we learn in a more Bayesian way when information is better than expected. I'll show you what I think was the first study showing this. And this, again, is quite an interesting study by David Eel and Justin Rao, two behavioral economists. What they did is they brought people into the lab in groups of 10, and they asked them to rate everyone else on how attractive they were, from the least attractive in the room to the most attractive in the room. Then they put everyone in front of a computer screen, and they asked them to predict where they stand relative to those 10 people. And the way they asked them to predict it is by drawing a histogram. So you basically say, I'm 0% likely to be number 1, 0% number 2, maybe like 10% to be number 3, and so on, okay? So you have the full distribution of their beliefs. Then they would give them a piece of information. And that information can either be good or bad. So they might tell them, hey, someone else in the room was rated number 1, the least attractive, right? This is great news because it's not you. Or they could maybe get a piece of information saying, hey, someone else was rated number 10, the most attractive. This is bad news because it's not you. And please redraw your histogram. So they did. So now they have everything that they need to compare the subject's posterior, this one, to a Bayesian posterior, right? And what they found was that when subjects got positive information, when they got good news, their posteriors look a lot like a Bayesian posterior, so textbook, right? However, when they got bad news, this relationship starts breaking down. And these are the average correlations. So when they get good news, the correlation between a subject posterior and a Bayesian posterior is about 0.85 or so. And when they get bad news, it's only about 0.5 or so. And there's been quite a few studies along those lines, all suggesting that we're more Bayesian textbook when we get positive information. However, when we get bad information, there's interference, and we're not doing what textbook equations suggest that we should be doing. So we wanted to look into the brain mechanisms to see if we can see what is going on and why people are discounting negative information, or at least what the mechanistic account is. So we conducted a few fMRI studies, basically using our update paradigm. And the first thing we looked at is how the brain was representing these estimation errors, because we found that they were important because they were basically teaching signals. And we found that positive estimation errors were tracked in quite a few regions in the brain, including the left inferior frontal gyrus, medial frontal cortex, as well as cerebellum, not shown here, all regions that are known to track errors. And we found that there was little individual differences here. However, negative estimation errors, their representation was confined to the right inferior frontal gyrus, and it wasn't tracked as closely. And how the brain was tracking positive and negative estimation errors predicted how likely people were to update their beliefs. It also was correlated with trait optimism, because people who are more optimistic showed more of an asymmetry of how they update their belief in response to positive and negative information. However, those frontal regions were not working alone. A study that we conducted showed that people with more white matter connectivity between the left inferior frontal gyrus and a host of subcortical regions that were important for emotion and motivation, such as the amygdala, parts of the striatum, even the hippocampus, those people with greater white matter connectivity in this system had greater asymmetry. And they had greater asymmetry both because they learned better from positive information, and at the same time, those same individuals learned worse from negative information. So what I'm showing you here is one example structure. This is the amygdala, and what it's showing you is on the x-axis is update, and on the y-axis is the fiber strength between the amygdala and the left inferior frontal gyrus. And you can see people with more white matter connectivity update more from positive, but less from negative. Okay, so this guy here, for example. This suggests, one speculation is that what this frontal region may be doing, it may be modulating activity in subcortical regions to amplify learning from positive information, and at the same time, perhaps inhibiting learning from negative information. And indeed, if you interfere with this system using TMS, so we conducted a study where we TMS the left inferior frontal gyrus, so we interfere with that region and then we do our task, what we find is that the asymmetry disappears. And it disappears because suddenly people become better at learning from negative information. So here are our control subjects where we TMS a visual part of the cortex that doesn't interfere with a task. And here are our TMS subjects. And you can see they don't have the asymmetry that we find in the controls because they learn better from negative. So this fits with our idea that maybe there's active inhibition, and that active inhibition is released when you interfere with parts of the frontal cortex. Okay, so we've shown that you learn more from positive than negative information. And we wanted to see whether you also learn faster from positive and negative information. We also want to generalize our finding to different kind of tasks. So to look at how, at the temporal evolution of how you learn from information, my postdoc, Donald Cahill, designed this task where you're playing a slot machine, and the slot machine can either be in a positive mode, where you're twice as likely to win or lose than lose, or in a negative mode, where you're twice as likely to lose than win. Now, the only thing you have to do is simply, after every trial, tell me, do you think you're in the positive mode or in the negative mode? If you're accurate, you get bonus reward, okay? So you play the slot machine, you won. And you say, well, I think I'm in the positive mode. And then you lose, and you say, well, I still think I'm in the positive mode. But then you lose again, and you say, well, maybe I'm in the negative mode, and so on and so forth. And you know that the slot machine will change states at a likelihood of about 1 to 6. So, and you get your outcomes. It doesn't matter what you think. If you won, you won. If you lost, you lost. That, you get that. But you get bonus if you're accurate. And so the question was, what are people's belief of the state that they're in, and how fast do they get there? Yeah?
Do participants know whether their guess was accurate, or do bonuses just accrue?
We don't tell them if they're accurate or not. Yeah, no feedback. Yeah, good point. Okay, so what do we see? We see that people tend to believe they're in the positive state, and for the same evidence strength, they would always more likely to say they're in the positive or negative state. Let me explain to you what this graph is. So on the y-axis is the percentage of time that they said they're in the desirable. Oh, I forgot the thingy. The blue is desirable and the negative is undesirable. So here is the evidence strength. So for example, this point here, it's a point where they won. And so 95% of the time they said, I'm in the positive state. But when they lose, only about 85% they would say in the negative state, okay? So with the same evidence strength, they're always more likely to say they're in the positive and negative. There's also this kind of interesting thing here where you see where the strength of the evidence goes up, the bias is smaller. This kind of fits with our idea that really if you have more ambiguity, that's where the bias would be greater. Okay, so they learn more from the positive, they have more positive belief, and they reach those conclusions faster. So when they reached a desirable conclusion, they reached it faster, this is log RT, than when they reached a negative conclusion. And before I go into what that means, why do they reach why do they reach those beliefs faster, I'm just going to show you another study that shows the same thing, but using a slightly different paradigm. The reason we did this is both because we just wanted to generalize it, but the second thing is what this task does, it lets you decide how much evidence you want. So you accumulate as much evidence as you want until you decide that you have a belief that you want to share. So in this case, what we did is we told the subject, you can be either in a TV factory or a phone factory. TV factories, sometimes by mistake, make phones, and phone factories, sometimes by mistake, make TVs. You have shares in the TV factory. So if you're in the TV factory, you gain rewards. And of course, it's counterbalanced. Now, all you need to do is you see the items go through, right, on the screen. And once you feel you know what factory you're in, you make your decision. And if you're accurate, I give you bonus points. The factory that you're in is predetermined on every trial. Okay, you can't change that. But you will get bonus points for being accurate. And again, what we see is that people tend to believe they're in the desirable state than the undesirable state for the same amount of evidence. So for example, this is a condition where about 50% of the time you see phones and 50% TVs. And in in the condition where you're actually in the TV state, about 75% of the time, you will accurately say that you're in the TV state, the good state. However, when you're actually in the phone state, the bad state, only about 45% of the time you would say in the phone state when you're getting half stimuli. And by the way, this half is your decision. You decide when to stop, okay? And so again, same thing, and again, they do it faster. Okay, so what does it mean that we reach these conclusions faster? It can mean at least one of two options. One option is that we have a response bias, right? Before you see any kind of information across the screen, you're ready to say, I'm in the good state. The other option, which can be true at the same time, is that we accumulate information faster when it suggests something desirable. So to disentangle those, what we did is we simply modeled our data using the drift diffusion model. So the drift diffusion model is basically taking the distribution of the reaction times when you make one response versus the other response. And based on this distribution of reaction times, it tries to estimate the factors that you use to reach that decision. So if you think about this as a threshold of saying desirable state, and this is a threshold of saying undesirable state, you start somewhere here, and we're interested, first of all, where do you start? Do you start in the middle, no bias, or do you start closer to a desirable response, right? And then you start getting information. So you see a TV, then you see a phone, then TV and phone, and so on and so forth. You accumulate this evidence until you're reaching the threshold. And so the second question is, what is the rate of this accumulation, what's known as a drift rate, okay? So using this model, what we found is that people have a higher drift rate for desirable evidence than undesirable evidence. And this is something that we found again and again, and I'll show you another replication of this using different experiments, replicating again and again. With regard to the starting point, in this one case that I'm showing you here, they did not have a bias in their starting point. So they actually start here without a bias, but they have a quicker drift rate when they get desirable evidence. However, sometimes this was the results of the first study that I showed you. In the second study, again, we find the drift rate being greater for desirable evidence. However, the starting point was significantly greater towards a desirable belief. So for here, we're getting mixed data. Sometimes it says, yes, you do have a biased response. Sometimes it says no. But for the drift rate, we're getting consistently greater drift rate for both desirable evidence and undesirable evidence, suggesting the accumulation is faster for that reason. Okay, so far, the data that I've showed,
Sorry,
yeah.
that experiment, couldn't you also show us the Bayesian so we can see which side's going sort of too much, too low? It sounds like that experiment had a correct Bayesian answer as well.
Well, there's a correct answer.
Right.
Yes, so it's unrelated to the drift rate. You're just asking,
No, I understand that, but I'm just
are they
asking,
more
like,
accurate given
Yeah.
that? Yeah, okay, so I don't know if my postdoc used Bayesian, but he used something that would get to the same thing, which is basically he said, what would someone's prior be given everything that they saw, and then what decision they will get to? And he saw that those decisions which are the correct, given the evidence that you saw, were not the same as the subject. So the subject had a bias when you compare it to what your belief should be based on all the evidence that you saw.
Asymmetry in that, because that's what I was particularly
Yeah,
interested in.
yeah.
So which case was closer to what they ought to be doing?
Yeah, the desirable one.
Desirable. So
Yeah, in some ways you can kind of see it here. I think I didn't give you enough information. So what I'm showing you here are in cases when they are in the desirable state, they say they're in desirable state, right? 75% of the time. These are cases when they are in the undesirable state and they say they're in undesirable state, 45. So this and this, it's not 100%, this plus that. Now, the one thing that it doesn't include here is our analysis based on what the prior may be according to everything that they saw in the past. And so when we include that, the model fits better. And I'm not sure why I don't have that results. There's probably something that's not yet done.
Just to follow up on that,
Yeah.
make sure I followed all the moving dots. So are you're less accurate?
Yes,
from
this
Bayesian
shows you,
for undesirable.
even without
Pretty
Bayesian.
accurate for desirable?
Yeah, so even just
You're not
ask
just-
about accuracy, just per se,
Yeah.
without looking in priors and all of that.
I'm thinking of everything, priors and-
Yeah, even just a simple, are you accurate or not? This blue line is cases when you are in the good state And so 75% of the time you say you're in the good state. I should have labeled this better. It should be like accurate, desirable beliefs or whatever. And this is cases where you are in the undesirable state. Yeah, it's conditional. And so all of these are actually accurate beliefs, and all of these are accurate beliefs. But you can imagine 100 minus this will be the inaccurate belief, right? Yeah, yeah.
So you've described this effect in two very different kinds of contexts. One where you can bring information to bear on the negative or positive information you've encountered. So know the rate of your chances of suffering from crime is not 30%, it's 40%. You can then think of the things in your life that you do to make that not apply to you. And the way that you summarize that result in this Bayesian analysis, well, of course it's more accurate in the positive part because you just accept the positive information. You counter-argue against the negative information. Do you think the same, does that argument apply here? It's hard to see what the work you're doing on the negative information to say, no, I'm in the phone condition, I'm not in the TV condition. What are people doing?
So
are there different processes in the two different contexts?
Yeah, I did say that they might be inhibiting the negative. I don't necessarily think this needs to mean that we're going through a very elaborate cognitive process. It could simply be the signals, the learning signals from positive are just inhibited automatically by, perhaps frontal lesions. I don't know if that's. So it doesn't necessarily mean, I don't know, it may, but it doesn't necessarily mean that we have to go through elaborate reframing and rationalization. We may do sometimes, but it may simply be that these signals are inhibited. It also may be that they're just less strong per se.
Is the transcranial stimulation experiment that you talked about consistent with this? That is, what's happening when you...
Right, so we did the TMS, but it's not that the people then go into the fMRI. So all I know is when I'm inhibiting it, it goes away. If I then put them in the scanner, I could see whether the signals are, which signals are being enhanced or reduced, and that would have been helpful.
You think it could be reduced inhibition or simply less excitation?
Yeah, so perhaps you could imagine, in that study, we don't see the signals in the subcortical, but let's say you take another study and you do this, you may imagine, the basic subcortical signals of positive and negative prediction errors or estimation errors, perhaps they're already shifted at that point. And there's enhanced activity in frontal regions, and then you might do some functional connectivity to show, well, maybe there's more connectivity or something like that. Or you may see that, in fact, the signals are being encoded the same, but then there's some other activity that is as a result. Yeah, I mean, you can think of all of these different scenarios. And when I get later on, I will talk a little bit at how this changes under stress, and it kind of touches on this a little bit. I agree with you. I mean, one of the reasons we wanted to do this is we wanted a case where it's actual outcomes, right? And you won't be able to say, well, I go to the gym, so it won't happen to me, blah, blah, blah. And it's more basic than that. It still may be some kind of inhibition, but it doesn't have to be. Yeah. Okay, so these studies suggest that we learn differently from good and bad news. However, biased beliefs can be the result of a process that happens before information even hits our eyes, at the point where we make a decision which information to reveal and which information to be ignorant of. And it's true that in life we often get information whether we ask for it or not, right? But we also make decisions on what we want to know. You decide if you want to get tested for a medical disease. Do I want to know if I'm carrying a disease, carrying a genetic mutation? Do I want to know how my students are rating my class, right? We make these decisions all the time. We Google. How do you decide what to Google? So again, classic models highlight the instrumental utility of the information, the idea that I will seek information that will help me avoid harm and gain rewards. However, human behavior often doesn't fit nicely with those models. For example, families with hereditary cancer often refuse to get genetic testing even when those tests are effortless and are free. So our idea, and it's not only our idea, others have said it as well, that the decision to reveal information is very much influenced by our expectations of how the information will make us feel, whether the information that we're about to reveal is good or bad. So to test that in a laboratory setting, we develop a task, and we've done a few tasks like this now, and they're loosely analogous to a real-world situation where you get an envelope, perhaps containing a decision on a manuscript. And you need to decide whether you want to open the envelope to see what's inside or toss it away. In our study, what we do is we have a gambling task, and we have win blocks in which on each trial you can either win $1 or win nothing. Or we also have loss blocks where you can either lose $1 or lose nothing. What you need to decide is only whether you want to know. Your decision is not going to affect the outcome, such as if you're not opening the email about the manuscript, your manuscript is probably rejected anyway, whether you know it or not. It's just affecting what you know in your head. So at the end of the study, we will give people the accumulation of all the wins and losses, whether they decide to know or not, but they just need to decide to know. And to help them make the decision, we tell them the probability of what they will find inside the envelope by using a pie chart. So this, for example, suggests that you're 20% likely to win $1. So you decide if you want to know or not. Okay, so what did we find? We found that first, people do want to know. Although this information is not instrumental, they can't use it in any way, they usually want to know. And they want to know more on the gain blocks than the loss blocks. Suggesting that they seek good news more than bad news. Now the question is, how does a decision to know, how is that affected by the probability of winning or losing? And there's two hypotheses that one can make. The first one is that the more I'm likely to win, the more I want to know. And the more I'm likely to lose, the less I want to know. So this is a desirability hypothesis. Okay? The idea is I'm going to press on the decision from the journal if I think I'm really likely to get in rather than I'm 70% likely. The other hypothesis is that what drives people's desire to know is to reduce uncertainty. And if that is true, then people should want to know most when uncertainty is highest. Uncertainty is highest when you're at 50%. Doesn't work. At 50%, right? That's when the uncertainty is highest. And if that's true, you should want to know most at that point. Okay, so what do we find? Well, our results look a lot like the desirability hypothesis, where people want to know more the more likely they are to gain, and they want to know less the more likely they are to lose. However, there's also a slight curvature that suggests that perhaps there's an uncertainty effect as well. We also ask participants at the end, we show them all the trials again, and we ask them explicitly to tell us, to rate how much you want to know. And the explicit ratings look the same as these decisions, where people explicitly say, I want to know more on gain blocks and loss blocks, and the same pattern when you look at the probability. They say, I want to know more, the more likely I'm likely to win. I want to know less, the more likely I'm to lose. Right. Okay, so this study that we did in the lab was actually inspired by some real work. One of the studies is by Carlson, Lowenstein, and Seppi, where they examined when do people want to know about how much they're worth, about their stocks. So when do they log into their bank accounts to learn how much their stocks are worth? And what they show here is in black is they show the value of the S&P 500 over 2 years. And in gray is a number of times that people log into their account. And basically what they see is that when the market is high, people tend to log in more. And when the market is low, people avoid logging in. What they don't show in this graph is what happened a few months later when the market collapsed. And that's when people started logging in frantically, right? But it was a little bit too late for a lot of people. Suggesting that maybe when negative information cannot be avoided, we actually, at that point, seek it out to collaborate our actions. And you see the same with Huntington disease patients. So although Huntington disease patients usually say that they want to know, or at least 70% say they want to know, they don't actually get tested until the symptoms are so severe that the answer is kind of obvious. But until that point, you see a relationship where when you imagine it's going to be positive news, you seek it more than when you imagine it's going to be negative news, right? If I think my students' rating are going to be terrible, I might just not look, but I think it's going to be great, I look to make myself feel better. Okay, so usually after hearing all of this data, people tend to ask, well, how in the world can this be adaptive? Right? If we seek the good news, we avoid the bad news, we update our beliefs more when we have good news and bad news, wouldn't that result in us underestimating risk, not taking precautionary action, and so on and so forth? And so many scholars have written about this problem. The one paper that I like very much is by Daniel Dennett and Ryan McKay. They basically go over all the cognitive biases that are known thus far, and they say that positivity biases are the only ones that are actually adaptive. And they raise a few reasons for this. Most of them are not new, but that if people have positive expectations, it is good for their health because it reduces stress and anxiety. And if we have positive expectations, it increases our motivation, our exploration, and that changes our actions. So that's why it's actually related to growth and so on. And we know, well, I'll show you in a minute, that negative expectations are related to depression. And I think all of that is absolutely true, and I agree with all of that. But my thought was that it may be true, everything that they say, in environments like the environment that we're in today, relatively safe environments, right? Maybe in those environments, these biases, their positive aspects of the biases outweigh the negative. However, in dangerous environments, you can imagine that a more balanced approach for learning and updating your beliefs may actually be more optimal. So our idea was that perhaps all of these asymmetries are not in fact set in stone, but they're rather flexible, and they change with the environment in a way that may be optimal. The idea is that if we're under threat, we have a physiological stress reaction, and that physiological stress reaction will change the way that we learn from information and the way perhaps that we seek information. So we wanted to test that, and the way that we test that is we conducted an experiment where we had two groups, a threat manipulation group and a control group. In the threat manipulation group, we had people come in, and we told them, you're going to do a task, the belief update task, and then we're going to give you a surprise topic, and you'll immediately have to give a 5-minute presentation on that topic. We're going to videotape you. We'll put it online. Everyone's going to watch you. You have no time to prepare, so it's going to be quite bad, right? And for the control group, we said, you'll do the update task, so we'll give you a surprise topic. You'll have to write about it for 5 minutes, and that's it. We won't read it. We won't judge it. Okay. To make sure that manipulation worked, we took their self-report anxiety ratings, skin conductance, and cortisol levels from saliva before and after the manipulation, and then we gave them our task. So first thing, just to make sure that the manipulation worked, indeed, all of our parameters show that there's enhanced stress in the threat manipulation after it than before relative to the controls. Okay, so what do we find in our task? The controls show the enormous bias in learning. They learn more from good than bad. But under threat, this asymmetry disappears. And it disappears because people learn better from negative information. So there's an enhancement here, a bit like the enhancement that we saw with TMS. And the more anxious people were, according to their self-report and changes in skin conductance, the better they learned from negative information, without a significant effect on positive information. And we then replicated this result outside the lab, so we went to firefighters in the state of Colorado. The idea of going to firefighters is that their days are quite variant, right? They can have very like relaxed days. They just sit there, watch TV, but sometimes they're quite have stressful, life-threatening events. And we wanted to know whether these changes are related to how they learn from positive and negative information. So we had them conduct our task while they were on duty, not while they were like holding the hose, but when they got back to the station. And we found that the more the firefighters felt they were anxious and stressed, according to their self-reports, the better they learned from negative information in our task. Although, to remind you, the events in our task have nothing to do with what they're doing on a day-to-day basis, right? So it's more of a general enhancement in negative learning without any effect on positive learning. It's definitely not significant, but if anything, goes in the other direction. So this was quite interesting because it suggests maybe this bias is not something that we see all the time, but it can change in a way that may be helpful. And we also thought this was interesting because it might explain a result that we published a few years later, and we didn't know what was underlying it. So the result was how people learn from positive and negative information, how that changes throughout the lifespan. And we examined kids from the age of 10 up until until the age of 80. And what we found was learning from good news didn't change much throughout age. However, learning from negative information did. So it was quite low in kids and teenagers, and then it went up, peaking at around midlife, and then it started going down again. Now, what you could see is that blue line is always above the red line, but there's this interesting change in how people learn from negative information throughout life. Now, we don't know what's underlying it, but here's one speculation. This is how stress changes throughout life. This is from Andrew Oswald in Warwick. And what he's showing that stress is quite low in teenagers and kids. It goes up, reaches peak at midlife, and then starts going down again. We know that if we manipulate stress, people change the way that they learn from negative information. So it's possible that just the stress that we feel in life and how that changes throughout life, that could be the cause of how the changes in how people learn from negative information. Interestingly, Andrew also shows that happiness goes the other way. So happiness is quite high in kids and teenagers, starts going down, hitting rock bottom in your midlife. But the good news is it starts going up again. And he actually shows that it stays up until the last few years of life. And that's true. He's done that in like 70,000 individuals throughout a lot of different countries around the world. And he also always showed that same U-shape. Now, if you think about how what we found about how people learn from negative information, if you flip that around and call it discounting bad news, you see the same kind of pattern. So this kind of U-shaped pattern in how people discount bad news throughout their life. Now, we don't know if there's a relationship between how good you are at discounting bad news and how happy you are, but we do know there's a relationship of how you discount bad news and how likely you are to have depression. So when we compare healthy individuals, and healthy individuals always show the bias, to people with depression, we've done this twice already, we found that in depression, again, there's no asymmetry. And again, the asymmetry disappears because people learn better from negative information. And the more depressed people are, according to Beck Depression Inventory, the more they learn from negative information without a significant effect on positive information. Now, we've done this twice. We've done this once. Everyone was clinically depressed. But our second study, they were clinically depressed, but they were not hospitalized and they were not medicated. When we then looked at people who are medicated and hospitalized, we started seeing an effect on positive as well. So positive start going down when you get to that type of population. So we know that depression is often triggered by a stressful life event. So it's possible that people who are predisposed to depression react quite a lot to these stressful events in their life. That stress then changes how they learn from negative information, really intaking all negative information. That then creates this pessimistic view and negative beliefs, which makes them more stressed, more likely to take in negative information, and so on and so forth. So it becomes a bit of a cycle. And this last thing, we also wanted to know whether stress, anxiety, and depression is related to how people seek information. Now, this is very, very new data. It's just one thing that we've done so far, but I will tell you what we found so far. There's a lot of work to do. What we found so far is that trait anxiety is related to information seeking, where people who are more anxious want information more, even if it's non-instrumental, and there's no difference in negative and positive information. They just want more information. So what you're looking at here is a correlation between trait anxiety and the likelihood of choosing information in our task. So I think this data is from the task that I showed you when they choose whether they want to know about their outcome. We also show in a slightly different task that they're willing to pay more for information. So they're willing to pay more. This is a y-axis here. And you may notice that my y-axis has negative numbers. This is because in this study, we gave people the opportunity to pay to avoid information. And some people would pay to avoid information. Now, this is pretty ridiculous because they can close their eyes, right? We never thought about this option until we already ran the study. And actually, the subjects don't think about this option either. And so some people are willing to pay to a little bit. You know, I think these are like in pence, but I'm not sure. So maybe like, you know, at most 10 pence to avoid information. But again, the point is, the more anxious people are, the more willing they are to pay for information, even when it's non-instrumental. So there's still work to do there. We're trying to look, if we stress people out, what happens then as well. Okay, so to summarize, we've shown that because emotion changes the information that you seek out, so the information that you end up in front of you, and because it also changes how you use that information to update their beliefs, our beliefs end up being not an accurate representation of reality, but rather a biased one. And these beliefs do affect our actions and well-being. So if you remember, I told you about the study that was conducted with 23andMe. So in that study, not only did they ask them about their perceived likelihood of having all of these diseases, they also followed up to see whether these individuals then made appointments to see a doctor, to take exams, and so on. And what they found was that how much people updated their beliefs was related to the likelihood of them seeking medical care. So you can imagine that if I update my belief in a biased way, that would change how much I will then go out to seek medical attention, and that could actually change health outcomes. So together with Cass Einstein at Harvard Law School, we're trying to figure out how we could use this new knowledge to maybe affect policy and affect the way that information and risk is communicated to the population. And so our first study is now coming out. I think that would be it. So just to thank all the people who've done the studies. So the students that conducted the studies. So Caroline was my PhD student. She's now at Caltech. She did the information seeking studies. Neil Garrett, who was my PhD student and just started at Princeton, he did the depression studies and a lot of the update studies. Christina, who's now a lecturer at Kingston, but she was my postdoc, did the developmental studies and the DTI study. Donald, who's now my postdoc, did all of the lottery machine studies and the TV phone studies. And all of our collaborators on all of these studies, especially Ethan Borwick-Martin, who's our collaborator in information seeking. He has a lot of really nice studies on information seeking in monkeys. If you don't know it, I suggest looking at it. Given that I have a few more minutes, I'll just tell you quickly about it. So basically what he shows is that monkeys will pay in order to get information a few seconds ahead of time if they're about to get a big reward or a small reward. Their reward is water, so they either get lots of water or a little bit of water, and he gives them an opportunity a few seconds before to say, do you want to know if you're getting lots of water or a little bit? They want to know, and they're willing to give up a little bit of water in order to know in advance. And he rules out the possibility that it's a preparatory effect. He only looks at the gain domain for ethical reasons. So that was another reason that we wanted to test humans. And my people who are funding me, the Wellcome Trust, and in the past, it was the British Academy as well. Thank you.
So we have plenty of time for questions. We're actually have the room till 11:01. So.
Okay. Yeah.
Go ahead.
So in your early work, I couldn't help, and I'm sure people did, think about the desirability bias. People just distort information in a positive way. And what's the relationship between your work and the desirability bias? I mean, you mentioned desirability several times as a sort
You
of...
mean the perception studies? Like I think the hill is less steep, because when I what is that study? There's a few studies where I need to go up. Is that what you mean, or what exactly?
So I'm not sure I have any one particular study in mind, but it just occurred to me that so much of the work you're doing involves desirability, wanting things to be true versus not wanting them to be true.
Absolutely.
And there's a notorious bias, wishful thinking, desirability bias.
Yeah.
And I'm just surprised that that wasn't mentioned in some systematic way.
Yeah, no, that's what I mean. When I said desirability, that's exactly what I mean. That is a desirability bias, exactly. Everything that I've said is explaining the desirability bias. What I'm suggesting is a mechanism that gives rise to that desirability bias. So if you mean desirability, I'm not sure what you mean by desirability. If you mean desirability bias as in people have biased perceptions, the Neil Weinstein stuff, is that what you mean? Like the optimism bias, Neil Weinstein?
Well, I don't know about optimism, but certainly a biased perception. They tend to overestimate the likelihood of events they wish to have happen and underestimate the likelihood of events they prefer not to.
Yeah. I'm sorry that I didn't. I mean, it's just, at this point, I feel like, sometimes I feel it's so obvious that I don't mention it. I usually have one slide starting with that. I'll put it back in. Yes, absolutely, sorry. This whole work comes to explain that. Yeah, and you're absolutely right. I should put that back and explain it. So what people call the optimism bias or the desirability bias is that people tend to have overly optimistic predictions where they overestimate the positive and underestimate the negative. And I think I probably have this. Why not? If I have time, so I might as well just show you that study. I was overly cautious in how long it will take me. Yeah.
No shortage of data.
Never. Yeah. Okay, it's not here. Anyway, I'll just tell you about it. You probably know about it. So yeah, the first Neil Weinstein study basically shows, he asked students to estimate their likelihood of having all negative and positive events happening to them in their life in relative to the other students in the class. And so he has a list of these positive events, getting a good job, having a gifted kid, and he has all the list of negative events, divorce, cancer, and so on. And he shows they tend to believe they're more likely to have this positive events happening to them than the other students, and less likely to have the negative events happening to them than the other students. And so my question is, where did this come from? And the answer that I'm suggesting is that it comes from a learning bias. So if we go, one of the reasons, and there's other reasons, and Martin Seligman talks about control, and that's another reason, and all of these are true. But where we came from is we suggested, well, this is odd because you experience a lot of different events in your life, and you get a lot of different information. And so if you were to learn from these experience and information in a balanced manner, it seems unlikely that you will then have these biased beliefs, this desirability bias that you're talking about. And so our hypothesis was that perhaps there's an asymmetry in how you learn from the information around you, how you learn from your experiences. And so if you learn a little bit more from the positive than the negative, at the end of the day, you will have this bias in your predictions, the desirability bias.
Because you could just be biased to begin with, but then learn differentially, and then it all gets corrected. It converges rather than diverges.
Right, so that's a very good...
Both of those could be true.
Yeah, very good. Yeah, and so the prior is a very important one as well. If we come into the world, and we could have just a prior saying the world is good, right? If I come in with a prior saying the world is good, then it makes sense for us to integrate the positive more than the negative. And this is one of the reasons, and that's true as well. But what we really try to do is say, well, even if we account for that, do we still see a learning bias? And that was the idea of doing, for example, the drift diffusion model, to try to separate those two apart. And then also in Bayesian models, such as the Eel and Raoult study, where they have the whole histogram. So they really have not just one point in the prior, they have the whole distribution of the prior, so they really can account for this prior. So even if someone comes with a positive prior, they can say still, we see this bias in how people take in positive and negative information. Yeah.
That was terrific. So terrific, in fact, that I want to revisit something we talked about this morning in light of the talk. So I suspect that if we gave a survey to everyone in the room and had them rate how articulate, smart they are, you would get this above average effect. People would be kind of Trump-like. I have the best words. And so that's a fact that fits with this optimistic bias. I also suspect that if you asked a bunch of people, a fair number of people here would have thought, oh, I think I'm going to ask, is this a good question? No, it's not. They don't ask it, and some people will walk out going, damn, that was a good question. Why didn't I ask it? So you're getting this shift to negativity. And I'm interested in the discrepancy. Those two things both seem real. They exist side by side. And so I sort of had three questions for you. One is, how does that fit your research? And one way of accounting for that is when you're thinking of asking the question, now the stress goes up, you're like the subjects in the stress condition. Is that how you would account for it? If not, how else would you account for it? And more generally, in all this work on optimistic biases, all this terrific work on optimistic biases that you've been doing, have you discovered pockets of insecurity, anxiety, not on the part of people who are depressed, just on the part of people in general?
In the domains that we've looked at, and we didn't come in with an intention of looking at different domains. It's just that, we looked at health for the simple reason there's just a lot of statistics on that, right? So that's why we looked at health. And also, of course, it's important to, just in general. Then we looked at, monetary and financial, again, just because it's easy. So it's not necessarily that we compared. And so we've never seen, as you call, a pocket where we've tried something and it didn't show this bias in learning. There is individual differences. So some people, on average, we see it in about 80% of the population. So 20% of the population will not have it. Out of that 20%, on average, half of them will maybe be clinically depressed, but half of them are not. So you do get individual differences where you do get at least 10% of the population who just doesn't have this asymmetry. There's no indication. No, according to BDI, they're not depressed, and so, and same thing with anxiety. There's trait anxiety and there's difference in trait and anxiety, and that relates to this. The question of why people, and again, it's the average prediction. Oh, this is something that we talked about this morning as well. The average prediction is better than the outcome, but the prediction can be negative. So, the example that I mentioned today is you can think, I'm going to lose a lot in the stock market, but then you lose more. That would still be an optimism bias, because the way that we quantify it is simply your prediction versus the outcome. They both can be negative, but the outcome is more negative than your prediction. So you can think, I shouldn't ask this question because it'll be very embarrassing. If it ends up really being embarrassing, that's still an optimism bias. But I don't like when you ask about why are people. People are obviously not always overly optimistic and biased about everything that they think about. And another thing that we talked about today is this is actually a really good study. It was published by Johnson and Fowler in Nature. I think it's 2011. It's a computational model, so not empirical data. Basically, what they wanted to do is to try and explain overconfidence, to say, is overconfidence optimal? In their model, they find that overconfidence is, in fact, optimal because it means that the agent is more likely to go after the resources than another agent that is not overconfidence, right? So the agents end up with more resources. And they show that that's true for all worlds, except when the losses are more than twice as likely as the gains. So in worlds where gains and losses are likely at the same way, which is kind of, it's not even a safe environment. In those situations, it's optimal to be overconfident. It's only when you get to the really dangerous worlds when it becomes not the optimal thing to do. And that inspired our work as well. But one of the conclusions they come up with in discussion is, under their model, these are the things that they would predict. And one thing is the temporal distance from the outcome that you're predicting. And we talked about that as well, that the closer you are to the actual event, the less overconfidence you become. And I think this also relates to the idea that as more things are more ambiguous, you will be more miscalibrated and more likely to have this bias. So it's possible when it's about to happen now, when people don't have this overconfidence. Yeah.
I was just thinking about this mechanistic that you have of inferior frontal cortex sort of sending this inhibitory signal down to inhibit the learning from negative information. But then putting that in the context of the lifespan data you have, where you have kids and much older adults who have reduced modulation of lateral prefrontal cortex, which would actually kind of almost predict the opposite direction of the findings. Well, how do you reconcile those?
Yeah. That is a very, very good question. And we thought about that a lot. I don't have a good answer for you. I don't know where the age difference is coming from. Now, perhaps if it is about stress, and that's what's underlying it, and the changes in frontal may not have a significant effect that we can see in the age differences. The other possibility is changes in dopamine. So we have a study that I didn't show where we manipulate dopamine by giving people L-DOPA. And when you give people dopamine, they learn less from negative with no significant effect in positive. A similar thing was shown by Michael Frank in his famous carrot study that was published in Nature. Using a reinforcement learning task, he shows that when you take Parkinson patients and you turn, either give them medication or turn the simulation on and off, you find that actually Parkinson's patients are better at learning from negative than healthy individuals. When you give them L-DOPA, then they learn less from negative. In his case, it's reinforcement learning, so it's negative and positive outcome. So we know dopamine is another thing that changes with age, right? And it is possible that that's another thing that interacts. But I agree with you, we don't have a good explanation yet of what's driving the age differences. And also, we don't have a good, this idea of the frontal is inhibiting, it's a speculation, right? And there's other things that don't quite fit. So we don't have a good, for example, we've tried to, so the idea, if it is inhibition, so on one hand, if it is inhibition, it should go away when there's no cognitive resources, like stress, right? But actually, when we reduce the cognitive resources, manipulate it, if anything, it becomes stronger in our studies. Some other people find the opposite. So that doesn't quite fit as well. So we don't have a clear idea. I can tell you, well, this is the mechanism we find so far. We don't actually know if it's active inhibition by the frontal lobes. Yeah.
I was wondering if you could say more about how your findings speak to other literatures that find negativity biases. And so, for instance, in other domains that often or sometimes positive information is treated somewhat similarly to neutral information, whereas negative information can carry more weight. And so, I'm thinking in particular of models that might show both a positivity offset, where you might have a default expectation of positive, but then the slope following that might, be more calibrated to negative information than positive information. So it seems like this is really different, and I'm wondering how you think about that.
Yeah. So I'm not sure what you mean, but and we've talked about that as well. That a lot of times when people call negative and positive information, for example, how do I learn about someone being bad versus someone being good? In fact, my motivation is to do the best that I can do, i.e. have good friends and not bad friends, employ people who are good and not bad. So I have a motivation to learn as accurately as possible. There's no motivation on my side to reduce learning from negative information than positive information. This whole negative positive change in how you learn is only when you have the motivation, right, to learn better from positive, because you have a motivation to have this positive belief. So in the TICS paper, that we wrote recently, we lay this out where we think that this bias will be seen. So we say the same thing. Sometimes it seems, I don't know, when can we see it? We think there's two conditions that are important. One is that you have a motivation to reach the specific belief. So if I don't have a motivation necessarily to think you're good or bad, it's not that I will learn more from information suggesting that you're good or bad. Okay? So I have to have a motivation to reach a specific belief, A, and B, the information has to be ambiguous. Although some of the new data from reinforcement learning suggests maybe that's not true, but that just came after that. So that was our thinking, that you have to have these two conditions for the asymmetry to play out.
So if you did many of your tasks thinking about somebody you hate as opposed to yourself?
Yes, we did that. We actually did that. So we this was a pilot. We never wrote it up. We tried to see when it goes away, and the only time it went away when it was a celebrity that people didn't like. It would be nice to do it now, actually. I bet you'll see a huge effect. At the time, it was, I don't remember who we used. It wasn't like, it was just someone that people didn't really like that much. Yes, it went away.
I think there, first of all, with regard to aging, there's a broad literature on the age-related positivity effect.
Right,
And
yes.
there's actually, there's pretty good insight now that older adults can switch that on and off, depending on whether the information is really necessary. And so in many ways, I think it's a conflict that people are managing between feeling good in the moment and actually gathering useful information. In some settings, it can be actually beneficial to not learn anything about information. For example, with regard to your stock market portfolio, you don't want to check all the time because otherwise you're going to be more likely to pull your, out of more risky stocks that have better gain rates in the long term, right? This Ariely has actually done some work in terms of bracketing. So what I think would be really interesting is to see not so much whether people do this or not, but to what extent people can modulate this as it is needed and make meaningful trade-offs, right? For example, looking at the Huntington's patients, in many ways they don't want to know, right? They only need to know at the point when they would have to make reasonable accommodations and kind of, change their lives because the symptoms become overwhelming. Before that, it's perfectly fine to regulate their emotions. And so in many ways, what we should be looking for maybe is not just where in the brain the positive versus negative bias are located, but is there some region that kind of modulates between the two and can switch them on, turn them on and off when we need them in order to reach the most beneficial outcome.
Yeah, okay, so there's a few really important points. One is where in the brain, so I remember, and remind me I forget. Second is about the Huntington patients. The third is about the stock market. They can use that information. And the fourth is a general instrumental utility. First of all, I'm not interested where in the brain something is happening at all. No. None of my experiments are interested in where it's happening. The reason I use fMRI is because it gives me insight to the computation that the brain does. I really don't care it's in left inferior frontal budget. It can be anywhere. My question is, what is the brain representing? Is it representing an estimation error? Is it representing the estimation error differently when it's positive or negative? Is it representing the expected value in one condition but not the other condition? So these are the questions that we're asking. It's not about where the brain is doing what it's doing. The second point is about the instrumental utility. So two small points and then a big point. Small points. The same paper in Huntington's disease has great data showing that when people learn that they have Huntington's disease, they change their life immediately. They get divorced, they get married, they get pregnant, they retire, right? So they're actually making different decisions based on this information. And so it's not 100% clear that in the case of Huntington disease, not knowing is the best strategy. Okay? On the other hand, they feel worse, but they make decisions that fit with the fact that they're going to have a short lifespan. That being said, you see the same exact data for diseases that you can do something about. So you see it for AIDS, you see it for cancer. There's a great study where females already gave blood for something else, and they already had the information of whether they have the BRCA gene, and yet almost 40% of the females did not want to get the information about the BRCA gene, where obviously this is like of huge instrumental utility. And then the stock market. Carson, Lowenstein, Steppe do the best that they can to show that it's not about instrumental utility, right? So they will try to control for whether the people intend to use that information by looking at, like, are they looking at the weekend when the stock market is closed, blah, blah, blah. So they really try to control for market volume. It's hard to do in a real world study. I think it's relatively convincing, but I'm not a pure behavioral economist or economist, so that's more someone else's field. What we do is, in our study, we totally control for instrumental utility. However, we do have other studies where we didn't control for instrumental utility, where people could actually use that information, we don't find that they seek necessarily positive. And this makes sense with our theory. I don't think people disregard instrumental utility. And if that's the point that you got, that's not my point making. Instrumental utility is important for information seeking. My point was that the need to seek desirable information because it affects our emotional state is one that's important over and above instrumental utility. That's why we control for it. Put in instrumental utility, it's going to be important for sure. And we find it in our own studies as well. If they can use the data, that bias can be smaller or even reversed if the cases where negative information can be used more than the cases of positive information. And I think that was all the points that I was going to make.
Yeah. So I just wonder, in studies where you ask people, oh, how attractive are you relative to others, how good of a driver are you? Did you ever ask them?
I never did any of those studies, to be clear.
But in question, so I just wonder, would you also want to like ask them what the next person thinks? Because I wonder if awareness of there being a bias that I think, oh yeah, the next person's also going to be more likely to say, yeah, I'm like more attractive or better driver.
About what someone else thinks about you?
Yeah, no.
About what someone else thinks about themselves?
I just wonder if people are more aware of the fact that there is a bias, even though themselves think, yeah, I'm smarter, I'm attractive, if that would influence their ability to learn.
I think there's a bias blind spot, right? So, I mean, I've never done any of these type of experiments, so, the Elam Ra'u is not my study. But, yeah, there's a bias blind spot, right? So, great work by Emily Pronin shows that people are not aware of their biases, but they have, they're much better at telling you that other people have biases.
I just wonder if that would impact your ability to learn from feedback, or if it would in either way. So
yeah, so I think for example, taking our tasks and saying this is a probability that another person would have cancer, whatever, Tim, you show less of a bias.
Yeah. Can you speak a little bit more about information seeking and the 180 it does when the negative information accumulates to a certain point?
Can you say that again, sorry?
Can you speak a little more about what you think drives information seeking when the negative evidence comes to a certain point? So you touched on it a little bit when you were talking about stock market and change when the market collapsed and people were checking things all the time. I think you see it now when people after the election, and if they were disappointed, they're checking the news all the time, even though it's never. So you have anything that we talk about emotion regulation and kind of positivity maintenance, so that you're motivated to be happy and you therefore block the information, that kind of goes out the window.
So I think there's three important aspects that drive information seeking: desirability seeking, uncertainty reduction, and instrumental utility. And so anytime you look in these like real life events, and as well as like just looking at stock market, as much as you try to control, you can't really control everything. All these three are gonna be important, right? So you can't explain. It's not that the behavior is explained by one thing. I mean, we know that, we're psychologists, or at least some of us are, right? We all realize that can be the thing. So you're asking why, when things are very negative, people start to think. So I think there's many reasons, but one thing is one thing could be stress, right? When you think, oh, it might be negative, might be no. Now it's like, it's bad. People are starting to stress out, and that could change the way that they seek information. So now we're trying to do experiments where we stress people out and see how that affects the way that they seek information. So far, as I said, trait anxiety just correlates with wanting more information. And I think that's probably true this is just speculation, right? But I mean, what's happening now is people just want more information, right? I'm not necessarily clicking on Trump is like doing bad stuff. I'm also maybe clicking on, oh, look, there was a great march and a million people came. So also on the positive. So I think that's probably kind of what we see in the real world. And I think the last few months was just like textbook example probably of all of this, right? Information coming in, people are like, no, it's going to be fine, disregarding it, until things were, yeah.
I just had a couple of quick questions. One is, in the studies that you spoke about, it was mostly evidence which was like obviously positive or obviously negative. Have you done any work where the information is more ambiguous or could be interpreted either way, and whether this works the same so that if you see ambiguous information, you're going to interpret it in a positive way? And the other question was whether you've ever done any kind of priming and shown that like by telling people about the negativity bias, you can reduce that bias when they're making the decisions subsequently.
Let me answer the first one and ask you again about the second because I was thinking about it. Okay, so I haven't, but there is actually, this gives me an opportunity to tell you about great experiments done in non-human animals. And this will be perception, right? So they've done this in birds and mice and horses and pigs. They give them, for example, they show a bird a red light, and every time there's a red light, they should press the left lever, and if they press the left lever, they get immediate reward, so this is great. They show them a red light. When the red light comes, sorry, the green light. When the green light comes on, they should press the right lever, and if they get that, they get a delayed reward. So this is kind of the negative, relatively negative outcome. Then they show them lights that are between red and green. And they need to either press the left or the right. They need to get it right. If they don't get it right, they get nothing at all, right? And what they show is that the birds, or mice or whatever it is as well, they tend to press the lever that suggests that they are interpreting the light as the good light, as a red light, right? Even when you get past the midline, closer to the like green bad light, they still continue pressing this. And again, like if they press that, they get nothing. So this is not good. Yeah. And wait, there was a point. Oh yeah, I remember the second point I was making. This was only true in animals that were in large cages with a lot of water and toys and so on. Once you put the animals in small cages without frequent water and no toys, there's no bias in how they press. Again, suggesting that stress can be modulating this and changing it. Now, it's a bit different because it's perception, and there's other different things about it that makes it. But yeah, so that suggests that animals, and I'm sure there's human experiments like this, tend to interpret stimuli in a more positive light.
So I don't know if your current paradigms get at this or the models that you're using, but I'm wondering if you ever think about the differences between tracking the information or an inability to track versus incorporating it into the value representations. And if you try to disentangle that, is it that people are just not attending to the negative information? Or if you somehow ask them, could they report it, and they are tracking it along with their...
Yeah, no, we do that a lot. So the one thing that we do is simply ask them at the end of the study, what is about the information, tell us about the information, and there's no difference in whether the information was good about, the memory is no different. And one reason that we first did our first fMRI study was kind of to get at this question, because we were interested in whether the encoding of these prediction errors, whether that was different at the time when you see information, or perhaps the encoding is the same, and for some reason you're not using it at a later time. And our study suggests that it is this kind of encoding or representation, encoding not the right word because it's kind of related to memory. The representation of it is different. But it's not encoding into memory. It's more the representation of what this outcome means in relation to my belief. And so I think most of the action, and we've done other studies that suggest that, is happening at the time that you see information. But it's not that you're not necessarily attending or remembering it. Yeah, and the other, as I said, this other German group made the paradigm even better by showing people information and asking for them to respond while the information was on screen. So really taking away any kind of possibility for attention. I mean, I wouldn't be surprised if there's a slight difference in attention as well, but yeah.
Well, I know you're all just eager to ask even more questions, but as they say in show business, leave them asking for more.
Thank you so much.
Let's thank our